Hello, in this video we're going to look at a production function with concave isoquants, and we're going to prove that they are concave. So let's prove that the isoquants are concave to the origin. Here is our production function that'll give rise to such concave isoquants. Going to get the marginal product of labor, which is just 2L. Marginal product of capital, 2K. We'll set up the marginal rate of technical substitution, which is the marginal product of labor divided by the marginal product of capital. And we get 2L divided by 2K, and that just simplifies to L divided by K. We're going to now take the total differential of the marginal rate of technical substitution. Keep in mind, when moving along an isoquant, K changes with L, so we're going to use a total differential. We need to consider that a change in L has a direct effect on the quantity of output and an indirect effect on Q through the change in K. So here's our marginal rate of technical substitution. And now take the total differential. And we're going to need a couple partial derivatives here. Going to need the partial derivative of the marginal rate of technical substitution with respect to capital. Plug that result in right here. We're going to get the marginal rate of technical substitution, the partial derivative of it with respect to labor. Plug that result in right here. Doing that, we get the following. So again, the partial derivative of L divided by K with respect to K using the quotient rule gives us minus L divided by K squared. And then taking the partial derivative of the marginal rate of technical substitution with respect to L, that just gives us 1 over K. Next thing we'll do is we will divide through by dl. So I'm going to divide the left-hand side of the equation and right-hand side of the equation by dl. So dl divided by dl, that cancels, becomes 1. Then we got dk over dl. And then we now have the derivative of the marginal rate of technical substitution with respect to labor. Okay, rewriting the last result. And note that the derivative of K with respect to L is just minus the marginal rate of technical substitution. It's just the slope of the isoquant. So minus the MRTS, it is just going to be minus L divided by K. So we're going to make that substitution. Could put minus L divided by K in on top here. Doing that and simplifying. So the derivative of the marginal rate of technical substitution with respect to labor is greater than 0. So instead of having diminishing marginal rate of technical substitution, we have an increasing marginal rate of technical substitution. So this proves that the MRTS increases with an increase in L, and that can only happen if isoquants are concave. If isoquants are convex, you have the diminishing marginal rate of technical substitution. That's not the case with this particular production function that we're using. Okay, that's it.